All right, guys, in this video, we are going to complete the section 4.4. We did part of 4.4 in a printed packet because there was so much to get. And so I just figured it would be a little bit easier for us to do that one printed. But we're going to complete this topic, this idea of you graphing with sine and cosines on paper, because the rest of this is not quite as much writing as what the other thing was. You're not needing as many graphs. Like, it should be more manageable to do by hand. So we're switching back to our normal types of notes for this. Okay. Now you are seeing the sine and cosine function on here. I've drawn out 2 periods of each so that you can see what they look like just side by side. But for the more detailed sine and cosine functions, you can refer back to that printed packet. Okay. So anyways, just as a reference, again, let's make sure that you get those redrawn just so that you can see them side by side comparison. You can always add some extra notes about each one over on the side if you so desire, because we did have that on the printed packet. So if you want extra info, feel free to add stuff about it off on the side. But anyways, all I really was looking at was thinking you probably need those graphs just to see them right there. Now, we're going to go on to this term called a sinusoid or sinusoid. I've heard people say it both ways. Now, that is when you talk about having a graph that can be written as a sine function. We talked about briefly in our last lesson on the printed page where the sine and cosine function look so incredibly similar. They honestly have all the same attributes except for where they're hitting the y-axis. So their inputs and outputs don't match up entirely. However, if you were to shift it over, right, if I was going to take this cosine function and maybe shift it to the right, pi over 2 units, that's going to look exactly like the sine function now. So technically, you can write a cosine function as a sine function as long as you write out the transformations correctly to show that it was shifted. So since you can write it as a sine function, we consider that a sinusoid. So both sine and cosine functions fit into this category, even though you see it just say the sine right here. Technically, a cosine will fit in this category as well. All right, so the A, the B, the C, the D, all of that jazz, that is going to be referencing how the different transformations take place within your sinusoid. In our last lesson video, we talked about how to find amplitude if you're given a graph. However, we have not dealt with how to do this type of thing if you're given an equation. So if you're given an equation, the way you can find the amplitude is by looking at the A value from that equation. That's the value that is multiplied in the front. That's also indicating your vertical stretch or shrink. Remember how amplitude talks about the height of the wave. So if you take an amplitude and you have it like an amplitude of 5 instead, it's stretched so that the wave has a height of 5 rather than at the parent function where it's 1. So what we want to look for with the amplitude is, yes, you're looking for that A value, but more specifically, we want the absolute value of it. Your amplitude is never going to be a negative because it is looking at a distance. So you don't need a negative value. That doesn't mean that negatives are not important, because negatives still indicate reflections just like they have in the past. But we're just going to look at the absolute value to tell what the amplitude is. So here we go. We're going to look at these questions here. And they said define the amplitude of each and describe as a transformation of y1. Now on question A, we're already working with y1. So we're not going to talk about that being a transformation because that would be silly. But we can still find the amplitude. All right. So we're going to look out for that A value. On here, I don't see a number written in front of cosine, which means that it is automatically an understood 1. So to get the amplitude, we're just going to be doing the absolute value of 1, which is 1. Try, if you can, to make it obvious that you're working with the absolute value bars. If you make it look like 1, 1, 1, like that, That's really hard for me to read. It looks like 111 instead of absolute value of 1. So do the best you can to try to make it look like absolute value bars instead of those bars being ones or something. Okay. All right, on part B, we're going to start by finding the amplitude, and then we're going to talk about transformation. So we're going to take that A value for that amplitude, and we're going to find the absolute value of it. Absolute value of 1/2 is simply just 1/2. Remember that absolute value bars do make things positive, but if it's already positive, it's going to stay positive. It doesn't just do the opposite of things. I've seen many people do that. It just will always have a positive outcome. All right, so that's amplitude. What about transformation? So if we talk about this being a transformation of the first one, the only difference is that 1/2, and that has vertically dilated it or shrunk, if you want a more specific term, but we're going to say vertical dilation of 1/2 from that y equals 1 equation. Okay? All right. Part C. Now this one. To get your amplitude, we're going to do the exact same thing. Take the number in the front, and we're going to put absolute value bars around it. So -3, but we're doing the absolute value. That results in an answer of just 3. Now, to talk about the different transformations, this guy, it's not just a vertical dilation of 3. That negative also does a transformation itself. That's going to reflect it across the x-axis. So we're going to say vertical dilation of 3 and reflection, or you could say flip, across x-axis. Right. So that's how that transformation would be worded. Fabulous. All right, let's talk about another idea. Period. We talked about periods of functions before. However, this is specifically in regards to if you have an equation, how are you going to find your period from that? And so it's a little bit more tricky than amplitude. There's a little math involved where you're just going to do a little division, okay? It says the period of a sinusoid is 2 pi over the absolute value of b. And that indicates the length of one full cycle of the wave, right? So it's a little bit tricky. You're not just looking and seeing how long does it take to get through. You are actually calculating it, which some of you guys will prefer to the graph. Just depends on who you are. So similar rules here on this example. They said find the period this time, and then we're still describing as a transformation of that first one. So starting off with sine x. Now, if you remember, this is the parent function. So if you remember what the period of that is, then you could just give that answer and not have to really show your work for it. However, if you don't remember what it is, then we'll do the solving. So period is going to be, again, 2 pi divided by the absolute value of b. Now, b is supposed to be whatever's multiplied to x. I'll bring you back to that. Here we go. B is this value in here. If you don't have a value there, then it's considered to be 1. So just keep that in mind, all right? If you don't see a B value, it's already automatically considered to be 1. Okay, let me get the camera back. All right, so I don't see a number in here. There's no number multiplied times that x, which means it's considered to be a 1, meaning my period would be 2 pi divided by 1, which is just 2 pi. So there's the period of that function. Now we've got to do the transformation part. So to talk about, well, no, I can't on this one because we're talking about transforming it from y1. So why would we do that? This is y1. All right, on to the next one. Part B, this one is a little bit more interesting. Now, some people might say there's nothing multiplied by x, it's just being divided. But remember that division is similar to multiplication. I could say that this value that was multiplied times x was 1/3, right? Division is the same as multiplying by a fraction. So if I were to try to figure out what b was here, I would say b was 1/3, and then go through my stuff like that. So to get my period, I'm going to say 2 pi divided by 1/3. And a fraction within a fraction is not ideal, right? We don't like to leave it that way. So we're going to change this to be 2 pi. And then when you divide fractions, you have to multiply by the reciprocal. You probably remember that phrase, keep, change, flip. So we're going to multiply by the reciprocal there. 2 pi times 3/1 is going to be 6 pi for the period. All right, so that was a little bit more work because we had that fraction there. That's okay. Transformation-wise, I'm seeing multiple transformations. We do have this guy happening on the inside right there, and I would say that that is because it's affecting the period, I want you to think about it even just in terms of a period. Normally, your parent function for sine, right, the period is 2 pi. This period was 6 pi. So that's definitely longer, and it's longer by a factor of 3. So it has been horizontally stretched by 3. Don't fall into the trap of saying that the horizontal dilation was 1/3. Okay. Remember, with horizontal stuff, you do have to flip it. So we're going to say here that there was a horizontal, I'm going to just abbreviate to shorten my writing, but horizontal dilation of 3. What else is there? Well, I see a negative in the front, which reflects across the x-axis. So we're going to say reflect across x-axis. And then that 2 in the front vertically dilates. So vertical dilation of 2. Again, just abbreviating to make that a little bit shorter, but you could write the whole words out. All right, fantastic. Looking at C. C has said find, or we've got 3 sine of negative 2x. All right, so let's see here. When we calculate the period, we're going to do 2 pi. So 2 pi. And then we've got to divide by the absolute value of negative 2. Well, the absolute value of negative 2 is just 2. So I'm going to say 2 pi divided by 2 like that, which gives me a period of pi. So if I compare this period to the original one was 2 pi, this one's pi. That is a horizontal shrink, right? It has gotten smaller. Now we still say horizontal dilation. We just have to make sure that we write it as a factor of 1/2 to show that it was half the size, okay? So we're going to say horizontal dilation of 1/2. All right, that negative in here, that reflects not across the x, but it reflects across the y. So then we're going to say reflect across y-axis. And then that 3 in the front vertically stretches it. So we're going to say vertical dilation of 3. All right, that would cover everything. You can always write it out nicer than that. I just was trying to fit it on the paper that I had there. Okay, cool. So we did amplitude. We've done period. We still need to talk about frequency. That's my next one. It's frequency. All right. I've got some more notes on here. I'm going to cover up part of that for just a minute so we can talk about it. If you want to pause the video here, feel free. You can always pause it and get stuff written and then keep the video going back once you get done, okay? But we're going to cover frequency. All right. If y'all remember frequency, we said that that is just the reciprocal of the period, but our last notes packet didn't give us details on what frequency actually meant. It really is just saying how many times is it going to have, is it going to complete a cycle within an interval. So, I mean, it's possible, especially once you start applying things to like the real world. You talk about a frequency of something, it's very possible to have a bunch of periods happen per second, you know? And so when we talk about frequency, it's talking about like the number of complete cycles in a unit, 1 unit, whatever it is that you are measuring there. Now, for a lot of things that we've had, our periods are pretty long. So we've just said reciprocal of the period, and it's made it easy to find that way. Keep in mind that to find the period, we took 2 pi and divided by the absolute value of b. So to get the frequency, you flip that, right? Absolute value of b divided by 2 pi. So my question here, I don't have a part A, B, and C. We're just given one equation, and they said find and interpret the frequency. All right. So looking at this equation right there, I'm going to first of all, I'm going to identify what the b value was, because I need to know what the b value is, and it's a little bit complicated there. This equation is 4 sine of 2x over 3, right? So that b value is going to be 2 over 3. Just grab that part. We don't need the x here, okay? So to get my frequency, what we're going to do is take the absolute value of b, which is 2/3, and we're going to divide that by the 2 pi. Now I'm taking a fraction and dividing by 2 pi, right? So in order to solve for that, I'm still going to do the whole multiply by the reciprocal thing. Keep, change, flip. We're leaving 2/3 alone. We're going to change to multiplication, and 2 pi, instead of 2 pi, we're going to have 1 over 2 pi, so that we can do that division. All right, multiply straight across the top and the bottom. That gives us 2 over 6 pi. You also could have gone ahead and cross-canceled if you're the cross-canceling type. This needs to be reduced if you don't cross-cancel beforehand. 1 over 3 pi is going to be our frequency, which means that's how much of a cycle goes through in 1 unit. It is not going to have a full cycle happen. It's just 1 over 3 pi cycles. If you wanted to know what the period was from here, you could just flip that and it would be 3 pi. So fun. All right, let's talk about horizontal translations. And for trig functions here, we call these phase shifts. That's a little bit more of a term that comes from some science fields where they actually apply this stuff and use it on a regular basis. So just go ahead and get used to that term. When we talk about a horizontal translation for a sinusoidal function, we're going to call that a phase shift, okay? It works the same way that our horizontal translations have always worked. So when you see that it adds a number, if you see that C value that's being added in here, if this is positive, more than 0, it's going to move left. So it's backwards from what it feels like. Or they'll say a phase shift of negative C. If C is less than 0, so if it's negative, then that's showing that it's moving to the right. It will have a phase shift of positive C. Okay, so it's a little bit awkward to get used to maybe that term phase shift, but yeah, we can still use those. It's still just a horizontal translation. So if they gave you a graph or an equation with showing a phase shift like that, you could just grab the number from the equation. Now, on example 4, they said to construct a sinusoid with a period of pi over 5, amplitude of 6, and it's going to go, through the point 2, 0. So this is a little bit of a different type of question than what we have seen so far on this section, but it's a little bit more of like, it's just creating your equation based on different attributes. Notice they didn't even say a phase shift on here, but that term is going to come in handy as we're working through the problem. I would also suggest that you keep a calculator handy because we're going to use that to our benefit in a few minutes, okay? All right. So for this one, they said we want it to have a period of pi over 4. So I want you to remember how you find the period of a function, right? The period is going to end up being 2 pi over the absolute value of b. Now, let's start with that. Let's start with period, just because that's the first thing listed. All right, so for period, They told me that my period was needed to be pi over 5. What that allows me to do is figure out what the b value is. Because in order to find the period, right, period is the same as 2 pi divided by the absolute value of b. So what I can do is I can set that up as a proportion. Really, we got a fraction equals a fraction, and we can solve this. I'm going to solve it by cross multiplying. If you like to solve a different way, then you can, but I would be multiplying this pi times the absolute value of b. So this is pi, absolute value of b. And then we're going to have 5 times 2 pi, which is going to give us 10 pi. If I divide both sides by pi, I end up getting the absolute value of b equals 10. And remember, absolute value just makes things positive. So technically, this value 10, it could have been positive or negative because the absolute value of it needs to be a positive number. So it could have been a negative number to begin with. It would have made it positive. Anyways, you have these two choices, positive or negative 10. All right, so that at least narrows down what b could be. Now let's talk about the amplitude. They said the amplitude is 6, right? So that means my amplitude, that talks about the absolute value of a. If the absolute value of a is 6, that means that a, without the absolute value bars, is either positive or negative 6. All right, so working this kind of backwards is a little bit more tricky because of those absolute value bars. You're not boxed in saying it has to be a positive 10 or has to be a negative 10. Here at this, you're not boxed in saying it has to be a positive 6 or negative 6. A reflection still could have happened even though it's not mentioned. Okay. All right. So let's see what we've got here, and let's try and see what this looks like. So I'm going to try with the information I have right now. I'm going to try a function that says y equals my amplitude. Let's pick positive 6 just to see. I mean, if it makes it better to reflect it, we will. And then we're going to say sine of, and then for my b value, it needs to go in here. Let's try the positive 10x. Again, if we need to change this up so that we reflect it some way, we will, but we're going to try this. And so you guys may not care for these types of questions quite as much because it's going to be very much like trial and error once you get it going. Okay. So for my first equation, I'm going to try to, I'm trying to get my calculator to be working with me this morning. Okay, so I'm going to try typing in, it's y equals, let's try 6 sine and then 10x. And let's see what this looks like, because really the only other parameter I need is I need it to go through the point 20. And we got to see if this is going to work. So I'm going to go look at my graph, and we're going to see, does this go through the point 20? Okay, well, I can go to calculate, find, let's see. Oh, no, that's not it. Go to. And let's see what happens when x is 2. When x is 2, my y, I don't know if y'all can see this. I know it's really zoomed out, and these, oops, wrong way. These calculators don't always show up super duper well on the screen. All right, when I plugged that in and I looked at where x was 2, this y value is like 5.47767. Okay, not 2. Okay, so something's not quite right with what we have. So we need to think about, what is it that we can do to change it? Is there a simple way to fix this? So I'm going to look and see, where is my y value 2? Is there a place where I can see my y value being 2 really easily? So I'm going to probably can shift it more than one direction. I'm going to try to reset it. Okay. Graph. It's not really giving me whole values at all. Okay. a little tricky. It's a little tricky to see it on this graphing calculator. Okay, so one thing we got to figure out is how are we going to get this to go through the point 20? What can we do to change this and get it to go through that particular point, right? So what I'm going to suggest we do is I'm going to say, let's go to calculate, hit find. Let's go to zeros because what we're looking for is 20, right? Let's see where the different zeros are for this function. And there is one nice pretty 0 at 0, 0. Now I want you to compare that to this 20. If I look over here at where the 2 would be, well, it's not on my screen, but we showed a minute ago that it's not going through the right point. However, I do know it's going through the pretty point 0, 0. And in order for me to show that it actually would go through the point 20, I could scooch this thing over to the right 2 whole units. If this is going through 0, 0, and I needed to go through 20, let's look at it having a phase shift of 2 to the right. That will make it go through this point instead of 0, 0. All right, so let's make a little note of that just so you have that as a reference. We're going to say this goes through 0, 0, not 20. So it needs a phase shift right 2. Okay. Oh, I'm sorry. That was not 100% there. There we go. All right. So we're going to try to see what this is going to look like. Let's try a phase shift. So the only thing we need to change in here, we're going to have this 10. But what we're going to do with this x is to move it to the right 2, we need to subtract 2 just to the x value. Okay. We can distribute the 10 through to simplify the equation out. Yeah. But this equation, and you can check it in your calculator, but this equation, it has the amplitude we're talking about. It has the period we're talking about. The only thing that we had to adjust past that point was to make it go to the right 2 so we could force it to go through the point we want it to. There we go. Boom, done. But it can be a little bit tricky to read on these calculators because they don't always scale the x the way that we think of. I'm sure there's a way to do it, but I'm not very great with the calculators. I like to do stuff without them most of the time. But if I find a good way to do it with the calculators where it's like you can see the scaling better, I will. But it shouldn't be too bad because the sine function naturally goes to the origin. Whereas like the cosine function would go through a maximum, or if you flipped it, it would be a minimum naturally. So anyways, let's go to one more question. We have here example 5 that we said construct a sinusoid y equals f of x that rises from a minimum value of y equals 5 at x equals 0 to a max of y equals 25 at x equals 32. So what you can do to start this is you can draw a picture if you're the picture type of person. So if I did that, okay, we'd have they said we've got a minimum. Here, this point would be 0, 5. Then it says it goes up to a maximum, and this would have been the point 32, 25. We're supposed to write an equation to model this. So we're going to have to use what we see here to really give us the things that we need. If I can specifically find the period and the amplitude, that's a really good start, just like we had on the example 4. So first thing I'm going to do is maybe see if I can figure out what the amplitude would be, because it should be going halfway between each of these, right? And so the amplitude would be the height or the distance between that max and the midline, or the min and the midline. So I'm going to look at between 5 and 25. The difference between those is 20. You cut that in half, the amplitude is going to be 10. Okay, so first things first, we're going to say that's the amplitude, right? Amplitude is going to be talking about the absolute value of A which would be 10. So a is either positive 10 or negative 10. What about the period of this function? So the period of this function is a little bit different because I don't see a full period drawn. So if I was going to see a full period, it would go from this minimum to another minimum. So pretending I could draw, we would need to see what this point would be. Well, this first one does start at 0, 5, which is pretty cool. And I can see that the x-coordinate goes from 0 to 32 just in that little span. So to me talk about the entire period, I would need this to go another 32 over. If you want that point right here, it'd have to be 64, and that y value would have to match. So the period here, I would say, is 64. And just like we had to kind of solve for the b value last time, we know that 2 pi over b is, or absolute value of b, is 64. And then you're able to figure out what the period is. So let's kind of go on a little journey here. If I multiply both sides by the absolute value of b, that gives me 2 pi equals 64, absolute value of b. Divide by 64, so 2 pi divided by 64 equals the absolute value of b. Reduce this, 2 over 64 is pi over 32. And that's the absolute value of b. Only other thing to look out for is this could be positive or negative for the actual b value, since that had the absolute value on it, okay? So when I write my equation, let's try something. Now, I also want to maybe encourage you guys to branch out and not just force yourself to use sine. You can use cosine too. And for me, I think it's going to be easier to use cosine on this one because they're giving me maximum points instead of zeros. Like on the last question, they'd given me a 0. It's easier to kind of see the zeros on sine. But here, because we're looking at minimums and maximum points, I would encourage you guys to try a cosine function. You can make sine work, but it's a little bit trickier. So I'm going to say let's try cosine, and let's see what happens. I'm going to rewrite up here just for reference. A is positive or negative 10. B is positive or negative pi over 32. That way I don't have to keep going up and down off the paper. All right, let's try a cosine. Y equals, and then it would have been, maybe try the positive 10. Let's see, cosine. And let's try positive pi over 32 and just see what happens there. Okay, so again, this is just, once I've got a good idea of what these values are, let's try it and see what happens. I know that's not our favorite thing in the world. We want to just have a concrete answer, but there's actually infinitely many correct answers on these. And so we have to be mindful of that and make sure that our answer is one that actually works. Okay, so I typed in my calculator exactly what you see on the paper. And this is what I have. Now, again, I need this to go through those particular points. And I'm not seeing that. So let's see. If I was looking at, see, that's 30, negative 9, 20, negative. So when, and then, yeah. So if I was looking at x equals 32, I don't get 25. If you look in here between 30 and 40, it's a negative output, okay? So that's not working out for me. So one thing that I do know is that if my x is 0, I need this to be going through 5, and it's not. Here when my x is 0, it's going through 10. That's a really, really easy tell that that needs to shift down, right? This is not good where it is, but I think all it needs to do is just shift down 5 units. Is that it? Then it may, oh, no. The other thing is that's supposed to be the minimum, not the maximum. So let's try something else. Let's maybe see what happens if I reflect this, because I want the minimum on the y-axis, not the maximum. Okay, so let's check. Go back. We're going to reflect this across the x. And now I have a minimum on the y-axis. However, I need that minimum to go through the point positive 5. It's going through negative 10 right now. So what we're going to do is maybe shift this up 15. Okay. So this, I'm going to say just as a little side note, we're going to say this shows y-intercept at 0, negative 10. So shift up 15. Okay. So that equation would instead, this is an easy fix, plus 15 like that. All right. That would work out. So there's a little trial and error involved, but you can do it. All right, guys. That's it for this video. I'll see you in the next one. Bye.